Welcome back, friends, to the part 2 of the lecture series on weldability of nickel based alloys. Now, having discussed the types of nickel based alloys, solid solution strengthen and precipitation strengthen, and their potential application, it's time to discuss about the effect of alloying elements in nickel based alloy. So we knew that chromium is also one of the alloying element in nickel based alloy. So here it's an essential element because chromium is forming a Cr2O3 surface oxide films that is very much required for corrosion resistance, and nickel has high solubility for chromium and a very narrow solidification temperature range when alloyed with chromium. So we'll discuss why this narrow solidification temperature range is preferred because it has to do with the cracking resistance. So chromium is an ideal element to form basis of most of the nickel based alloy, and significant strengthening can be achieved through formation of precipitates Ni2MOCr phases in a nickel based alloy. Apart from chromium, there are also alloying elements like aluminum, titanium, and niobium are added. They are working as strengthening precipitates in high temperature alloys because aluminum and titanium promote formation of Ni3TiL in the matrix of face-centered cubic structure. So they provide excellent high temperature strength. But these alloys, particularly the high temperature, alloys with aluminum, titanium added precipitation strengthened alloys are suffering from strain edge cracking during post-weld heat treatment process, and sometimes they are less weldable. And if niobium is added, the formation of Ni3NB precipitates is also promoted, and this is also one of the strengthening mechanism. But this niobium strengthen are relatively immune from strain edge cracking, but these niobium rich eutectic phases during weld certification renders certification cracking issues. So this aluminum titanium added precipitation strengthened alloys face the issues of strain edge cracking during post-weld heat treatment, and this niobium added precipitation strengthened nickel based alloy are suffering from certification cracking. Boron and zirconium are also added to improve the elevated temperature creep strength, but they have a detrimental effect on the weld hot cracking resistance. And most of the nickel based alloy containing alloying element like chromium, molybdenum, tungsten, tantalum, titanium, and niobium, they are most of the time carbide formers. That is why carbon content is kept as low as possible in corrosion resistance alloy, because for when the alloys are designed for corrosion resistance applications, we have to make sure that the level of carbon is below 0.01 percentage weight. Low carbon levels prevent the formation of carbides in the heat affected zone, which may impair the overall corrosion resistance of these alloys by depleting the austenitic matrix of critical alloying elements like chromium and molybdenum. Because lower the carbon, lower will be the issues of sensitization. Carbon levels are intentionally higher in high temperature alloys, typically in the range of 0.05 to zero point 0.1 weight percentage, to form strengthening carbides. And aluminum is also sometimes added to high temperature alloys because aluminum provides Al2O3 oxide films on the surface of the alloys. And our composition must get away from the sulphur and phosphorus and lead because they are low melting point alloying elements. They are low melting point elements and they have a adverse effect on the weldability. Particularly, they are insoluble in nickel and promote hot cracking by forming a low melting point eutectic phases. And magnesium and manganese are added to control the effect of sulphur by forming Mn and Mns. So hot cracking in nickel and nickel alloys. The issues are, you will see from this graph that nickel and many its alloy are prone to hot cracking in the weld metal due to sulfur and other impurities. So what do you see in this graph, that at 635 degrees Celsius there is a lack of solubility of sulfur, and it forms eutectic at this temperature 635 degrees Celsius, right? So this eutectic phase is major problem with precipitation hardened nickel base alloy, and they are giving rise to hot cracking issues in weld metal and heat affected zone. So this table is an extract from the very good research, very good review paper on weldability of nickel base alloy, authored by Jeffrey F. Sowards. So this table contains the classification based on the application, like corrosion resistant application, high temperature application, and the alloy system like solid solution strengthen and precipitation strengthen, and their commercial alloy examples and main weldability concerns, like say for example, corrosion resistance material like nickel chrome molybdenum are most of the time facing weld metal and heat affected corrosion. Then this say alloy X liquefaction cracking issues, then precipitation hardened material Vespalloy are suffering from strain edge cracking, and there are also mention about the some advanced uh, materials or alloy system like nickel aluminide oxide dispersion strengthen and single crystal superalloys. They also have some challenges during and weldability concerns. So this is a very good table for looking information about the weldability of nickel based alloy. So in our next class, we'll be discussing various weldability issues. So till that time, stay connected and keep watching my channel, and I'll be right back after. Thanks for watching.